So now, so we went over, so this, our topic now, we're still talking about integrity and hash functions, but in the previous lab, we focused on hashing with OpenSSL, not really the algorithm, but just using it, being able to have a tool for that. In this example, for homework, we're going to actually look at the algorithm. All right, so how do we implement an XOR hashing algorithm? So this is the lecture from Tuesday, so you can go back to that discussion. And of course, we need to use the XOR you know, um, primitive that we defined in the previous Python script. So now we're going to do XOR hash. So this will just be one problem, essentially, but it is a coding problem. Okay, so let's go on the description. Okay, so one problem, as you can see, Python XOR hash. So complete the following problem as done in class. Submit a report showing evidence that you completed the Python XOR hash cipher. Let's discuss. You need to run it without errors and show evidence of calculating a hash. Please don't just give me the code, right? So you have to show me that you got it to work. Um, you know. All right, so that's that. So I'm gonna create, so now let's see just looking at what I did last year. So we're already doing this one SSL, so I won't repeat. But I do recommend that you use a somewhat of a long message. All right, so I'm gonna delete this. Okay. And I'm gonna add the assignment for this one. Assignment. Okay, so this will be Python XOR hash, right? So we're gonna code this hash homework. Any questions, guys? All right. So this will also be due on the 18th by 10 p.m. Okay, so start date, the 9th, and it'll stay open until the 21st, right? So you have until that Sunday. So complete the hash coding problem as indicated in the attached Word document. Okay, so that's essentially what we're going to do. So make sure let me know if you have any questions. You don't understand the assignment. And now we're going to go to the virtual machine and just kind of implement the algorithm. This is technically your first real algorithm. XOR was just doing the XOR operation, but this is now algorithm. And so, a secure type of an algorithm, right? So let's go to the VM. Let me see where I am. Yeah, so I'm in hash, I think. Yeah, let's stay here. All right, so we're gonna create a new script. So nano, so a new coding sample. Remember, this script is on the GitHub hash XOR. Yeah, so it's gonna be similar, but there's a few tricks to it. All right, so we're gonna implement a hash algorithm here. So I'm gonna copy actually the XOR first example and build from that. Okay, so let's go ahead and do that. So let's take a look at XOR. So XOR first. Yeah. Right, so I'm going to copy this one as I'm building on top of this, and we just did, but we need to, add more complexity. So let's dash L. I'm going to CP XOR into, let's call this one hash XOR. .py. Okay. So I should have now a copy of XOR first, and I'm going to start building on top of that. Any questions? Oh, all right. So I'm going to continue. Hash XOR is now my problem. Okay, here we are. All right, so remember, review again the XOR problem. We just had the library. We had a gen key. We had an encrypt. We had a decrypt. And then we had the main section with all the different things. But the thing that was easy about it was that we just used this as a block. Now I need to define a block size, but I need to have a message that is longer than the block, okay? And then I'm gonna have to break that into individual blocks. Does that make sense? So that's really the difficulty of this, all right? And then as you guys will see later on when we do confidentiality with ECB or CBC, it'll be similar to this, but with an added complication. All right, so let's first pick a message that's much longer. So I'm gonna do. So now I'm gonna change the plain text to be. This is a top secret, but it's gonna be longer. I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then I'm gonna say AA, BB, CC, DD, EE, FF. GGHH, IJJKK, LLMMNN, OOPP, QQRR, SSTT, UUVV, W, two W's, XXYY, Z's. All right, so we have something a little bit longer, so we're going to have to break this up into parts. Okay. So we can print the message. Now, instead of calculating the length of plain text, we're just going to find the length of the block. So the length of the block for my example is going to be 8. So I'm going to break that block into 8. Remember that we might have the problem that the last block is not a perfect block of size 8, so I'm going to have to do padding as well. All right, so all that needs to happen. I'm going to print the length of plane. That's something I can do here. So length of plain text. Plain text. There we go. All right, so I'm done that. Here is the trick now. Usually here we would just create the key and encrypt. Now we have to create blocks. Okay, this is a very important part in symmetric encryption. Um, getting the blocks. So I'm going to do, because a lot of these algorithms for confidentiality assume this idea of blocks. So I'm going to create a thing called list of blocks. So list of blocks. Okay. And so I'm going to need a function that takes my plain text plus the length that I defined, which is 8, and produce this list of blocks with padding and everything. That's essentially what the key is here. So create blocks. And so it's going to be plain text, comma, length. So length, so just like that, okay? So obviously I haven't defined that one. After that, we're going to need to create the key. The key should match, to simplify things, the key should match the size of block. So it's going to be 8. And then the encryption now, instead of doing something like this, encrypt directly, we need to do an algorithm. So I'm going to say hash function or hash algorithm, which instead of taking the whole plain text, will take the list of blocks. The list of blocks. Okay. And it'll take the key itself. Make sense, guys? So we're going to have our message. We have the list of blocks. We have the key. And this should produce, instead of a cipher, remember, we're doing a hashing algorithm. So it should produce a hash value. Okay. Produce a hash value. Any questions? All right. So it produces a hash value. So we can go ahead and print the hash value here. Hash value, okay. And then we're going to have several ways of like displaying it, etc. And that's essentially it. Remember that these algorithms don't like encrypt and decrypt. This one just goes sort of forward. So I'm going to delete all of this. I'm going to delete these. This should be wanted to be like a hexadecimal string or something like that. And so I'll show you guys, there's several ways of like printing this. Can view it similar to what we saw in OpenSSL. Okay, so great. So we've done all these parts. Now what we need to define is the first function, probably the hardest one, is create blocks, right? So we have to create a list of blocks, maybe not so hard. And then after the hash function, it's just the function that we discussed on Tuesday, the XOR algorithm, which if you remember was pretty straightforward. Okay, so go ahead and create the function here. As a separator. Okay, define. Okay, here we are. So let's go ahead and try this out. So create blocks, right? So that's what we want to define first. Create blocks. Okay, so this one takes in the actual message, the long message, and then it takes also the length of the block. So I'm going to say plain, comma, block size, just like that, block size. Okay. All right. So how do we do this? There's several ways of doing this. But I'm returning a list. That's one thing that's been established. 1, 2, 3, 4. So let's create a list temp list of blocks. Right? So that's my list of blocks. I'm going to now, from the plane, extract the blocks and check for padding, essentially. And once that's done, I'm going to append them to my list. Okay. So 1, 2, 3, 4. So, another for loop. So for I in range. For I in range. Okay. Here it's gonna be so the limit is, so we're gonna go from 0. Let me do core. So we're gonna go from 0, the first index, to the length of plane, right? That's the whole file. But Python for loops have this really nice feature that you can specify a step. So this will allow us to like slice out the pieces that we want very easily. So the length should be equal to the step size. So that's the block size. Right. So every 8, I think it was, we grab it, then the next 8, then the next 8, grabbing the chunks as blocks. They're all the same size, but we do need to check for padding. All right, so we've done this part. 1, 2, 3, 4. 1, 2, 3, 4. All right, so now here is my block. We just grabbed it, right? Or we're gonna assign it to this variable, and I'm just gonna grab plane. And this is a trick I'm sure you saw in your very first programming classes. So you did something like I to I plus block size. Right? So if we think about the first one, 0. So 0 is the first index, 2, 0 plus block size, which is 8. Then when the index advances, it's going to advance by step size, block is 8. So the next time it'll be 8, right? Plus 8. So from 8 to 16 and so on. So we go 0 to 8 and 8 to 16 and so on. Okay, so that's it. That is a nice way to grab our blocks. Add a little bit more space here. So we got block name, I plus block size. And that's it, right? So if it wasn't for the padding, it would be done, but we have to check that these blocks are size 8. Otherwise, our program will error out. So I'm going to do if len block equal what? Block size, right? But if it's equal to block size, then good. That's exactly what we want. Size 8. 1, 2, 3, 4. So what do? We just append it to the list. So temp list blocks dot append. Or block. That's it. Pretty simple and straightforward. Okay, now so else it doesn't meet that. So that's the case where we need padding. So else it does not meet that. We need padding. So 1, 2, 3, 4. So how do we do this? Many ways, right? Many ways that you could do this. This is just one example. So I take block size, which is 8, block size, which is 8 minus the length of block. So we have to imagine that the last block, for instance, has 3 characters, right? It's size 3. So we would say length of block. Okay, so that's 3. We want 8, so 8 minus 3 is 5. And so what does that mean? We need to add 5 padding characters. Do you guys see that example? All right, great. So that's it. So I know C controls the difference. So given that many ways of doing this, it's a simple example for I in range. For I in range, let's see, right? So for I in range, you saw 5, for instance. So I need to add that to the block. So I'm gonna do underneath 4, 1, 2, 3, 4, and I'm gonna make my block equal block plus, and I'm just gonna add a space, okay? So I'm just adding a space so that when so later on this will become handy, like when we're decrypting, we don't have strange characters in there. It'll just print out a whole bunch of spaces. Okay. Oh, did I? Okay. Attach this. Attach block. Thank you. All right. Any other questions, guys? Yeah, please.
Do cover the law?
Yeah, so in Python, 2 equal signs is for equal, and then 1 is for assignment. Yeah. Any other questions? All right, great. So I can't stress how important this code is because a lot of the desk code, CVC code uses the exact same approach. Just that the algorithm just increases in complexity, but they're very similar. What this should show you is also it's very interesting how encryption works, right? Especially for confidentiality. This is it. And as we keep going and get to death, etc., you'll just see that there's additional steps that are added to add more complexity. But it's all based on that one-time pad idea that if the key is random enough, and as long as the original message, that's a pretty good encryption. You see that we can't achieve it, so we follow that idea, but add more steps to it. Okay. All right. So yeah, so great. So I have my padding done. And once the padding is done, of course, I'm just gonna append it to the list. So this is gonna be temp list blocks dot append, and I'm going to add to it, my actual block. So this block now has the appending done for it, and we are absolutely done with this. So now you just have to return 1, 2, 3, 4. Make sure the alignment here is good. Otherwise, it'll give you an error. So return temp list. That's it. All right. So this code hopefully will run. So let's try it and see if we get the list of blocks still in plain text, but we should be able to have one now. Temp list blocks. Yeah, okay, so this we want to print. That wasn't printed. So let's print it out. It's going to be list of blocks, just like that. All right. So let's take a look. And some of this will error out, so we'll get this will break down here. but we have to find that function. Okay, so clear. We're doing hash XOR Python 3. Right, so um, okay, did it work? Yeah, it did, right? So this part here, of course, was the error out, but we really are just looking at this part here. And you guys can see that I've managed to break it into blocks. So this is one block. This is the next block. This is the next block, the next block, and so on, all the way to this one. And notice that this one has padding. Any questions? All right, perfect. So now that we've done this part, we have our list of blocks. Now we can proceed. What are we going to do? We're going to take these individual blocks and XOR them with a key, right? And remember that at the end, we just want one final block, which is the hash, equivalent to the hash found. In the future, when we apply this same technique for confidentiality, we need to save all these individual blocks, right? And they're going to be the cipher that we send. And then in reverse, we have to take all those blocks and bring them back to the plain text, all with XOR. Okay, so let's go ahead and go back to the editor. So nano paste. So we've done create blocks. Okay. The next step is once we have the blocks, we're going to generate a key. Remember that this key is exactly the code that I did before. So it's a byte array already printed. And now I'm going to have the actual algorithm. So this is the actual XORing algorithm, which will take the list of blocks, the key, and it should produce a hash value over here. So we need to now define hash function. So let's go ahead and define that one. Just have it somewhere in here. This is probably a little bit more complex here and there. Okay. It's called hash function. Hash function, colon. This takes list of blocks, list of blocks, comma, key. Okay. So this is what we're doing. Okay. So can we use the encrypt function that we already wrote? Maybe, right? So the encrypt function that we already wrote um, took what? It took some kind of, it just assumed that the plain and the key had the same length. And this was a block, and this was the key. And we would actually just XOR them, and then it would return a byte array. Do you guys see that? So essentially, this function can likely be reused in our algorithm to keep it simple. If you understood this one, then it just makes it easier to understand. Then we're going to use it. Any questions? Yeah, so hopefully, that one just did one block. Now we're going to iterate through the blocks in a specific sequence or logic and produce the next block to use. So let's try that, okay? So 1, 2, 3, 4. Okay, we're going to implement the cipher. So we get the key. Let's assign that to cipher block. Cipher block. So the initial one is just going to be key. Okay. So we take that key and the first block, we're going to XOR them. That produces a new block. We assign that new block to cipher block, right? And then now we use that cipher block with a new plain block, XOR it, and keep repeating that. So we have this here. Now I'm going to iterate. Now, the nice thing about having my list of blocks is that now I just iterate through the blocks. So I'm going to say for block in list of blocks. Okay. So I can just, and here I have two spaces. All right. So list block. So for block and list of blocks. So this will allow me to iterate, grab a block, then I grab the next one, then the next one, and so on. So 1, 2, 3, 4. 1, 2, 3, 4. Print. Let's do print block just to see what happens. So I'm going to take, we should see like the blocks. All right, let's try it out. Make sure there aren't any errors. And as you guys can see, whereas before I had all the blocks in a list, now I'm able to iterate through all of them. Do you guys see that? So that's what, what I'm going to do now is grab each of those blocks in plain text, convert it, XOR them with a key, produce a new block, which is going to be used for the next step, and so on. Okay, clear. Let's, and we're almost done. So let's go over here. Print block just, so that we can see it, see the process. 1, 2, 3, 4. We have a cipher block. 1, 2, 3, 4. So now what we want to do is we create cipher block by just using our encrypt function. So I'm just going to say encrypt when I had previously defined, and I'm just going to give it the block and the cipher block, which for the first case is the key. Got it? All right, so that's it. So encrypt block, cipher block that produces cipher block, and then now you can see in the next iteration the result of this operation, right, will be used here with the next block, and so on. Right? Once we finish that, we're done. Actually, look at how simple this was. And then 1, 2, 3, 4. We just return. What do we return? The cipher block. Very good. That's it, because that's actually the last, that block is our hash. Exactly. Very good. And that's it. That's it. That's the hash XOR algorithm. One of the simplest approaches. All right, and then there's various ways of looking at it. But this is really the whole algorithm. Let's try it now. Let me just make sure. So the algorithm hopefully is done. But let's see. So the function gives us a hash value and we should print it out, right? And so let's try it. And there it is. This is the result, right? It's in a byte array format. So what we want to do now is probably change, it's a byte array. Let's just change it to other formats like hex, etc., so that it looks a little bit more like what OpenSSL gives us, right? But essentially, we're done. Okay, but you may not be able to use it so well like this. So we want to change the formatting and be more consistent with OpenSSL. So let's try a few things. So I'm going to go into code. So I have here, like if you look, I have several ways of displaying this. All right, so I'm going to add another print statement here. Okay, and this one should be hash value. dot hex. So take the byte array, target typecast it to hex and see what happens. And that one already looks kind of good, right? So notice I just changed this format to this format. It's a little bit more readable, more like something you can send via email, for instance. We're going to look at, let's just look at more options here, just to play with it a little bit more. But I mean, we're pretty much done. Let's do. So hash value dot hex, and then let's typecast it to an int. And yeah, and then let's do bin here. Yeah, let's try this one. Yeah, so you can see last semester, a student, I remember they asked me, they wanted to see, because we would do this in zeros and ones. So they just wanted to see the result in zeros and ones. So this is how you can go about doing that. I mean, this is just if your own curiosity. And there's another one here. Should be hash value dot hex. Same thing, 16. Int. Int. And then dot C4. See, these are just, it's the same data, but in different formats. What did that give me there?
Yeah.
Oh, did I? Yeah. Right. So pretty much the same thing. Notice it's got a B for binary in the front. But anyway, this is just student, because of the way that we did the problems by hand, he just wanted to see these byte arrays in zeros and ones. So if you want to do that, you wouldn't really practically use the zeros and ones. You'd probably go with the hexadecimal. Notice why do we have hex? Yeah, go ahead, please.
Oh,
It means binary.
oh,
It's telling you the format. You'll see this later on, and as we convert things, we'll put that in front to indicate what it is, because it could be a string. You see that? Now notice this is a perfect example of why do we use hex sometimes? Because the sequence of actual zeros and ones can be pretty big, right? And hard to read. The hexadecimal is shorthand, a little bit better. Got it, guys? Does this make sense? All right, that's it. So I'll stop here. The video, so